Okay, so in this video we are going to deal with solving equations with indices, okay? So this is a typical equation that we're talking about, and it's very different to anything we've come across before because, of course, the x, or the unknown, is the power, all right? Now, up to junior cert level and leaving cert ordinary level, the only way that we can deal with solving for a power is to basically make the left-hand side look like the right-hand side. And when you make them look similar, we should be able to pull out what's equal. Let me just jump straight into what I mean by working through this example here. We see here on the left-hand side, we're talking about a power of 2. So immediately that gives you a hint that we need to try and make the right-hand side look also like a power of 2. So this is where your laws of indices come in, okay? And your laws of indices we go through in another video. So if you haven't looked at that yet, it is worth going through that video in detail first, okay? The other thing I want to add is that the laws of indices are, of course, in your log tables on page 21, okay? So this always helps remind you of the different ways that we may be able to manipulate what we have here. With this one though, we just want to consider it and change it if we can to look like the left-hand side. And since the left-hand side is a power of 2, we want to basically make 4 a power of 2, okay? By all means, you might want to use your calculator here if you're not very familiar with what numbers result from what powers, okay? But your calculator will help you out if you need to do any bit of work on that. 4, we can write as a power of 2. It is, of course, 2 squared. Okay, so rewriting the right-hand side as 2 squared, and the left-hand side, of course, is 2 to the power of x. Now we have the left-hand side looking like the right-hand side, and this is where we can now pull out our answer. That means if 2 to the power of something has got to equal 2 to the power of 2, that means the something must equal the 2. In other words, x is equal to 2. Okay, now that is our approach with all of these kind of equations. You're always going to try and manipulate it so that your left-hand side looks like your right-hand side. So basically you're going to manipulate it so that the left-hand side looks like the right-hand side, and then we can pull out what's equal. Let's jump straight into another example here. Let's say you have 3 to the power of x is equal to 27. Pause the video if you want to give this one a go, if you feel confident enough. Otherwise, listen along now and we'll go through it. So we can see here we've got a power of 3. So that gives us an idea as to what we want to make the right-hand side look like. So can we make the right-hand side a power of 3? So again, if you need to go to the calculator and see, can you work with powers of 3 to get 27? If it doesn't jump out at you straight away by just looking at the number, what the power of 3 might be, then use the calculator. 27 is 3 to the power of 3, because of course 3 times 3 times 3 is equal to 27. So yes, I can write 27 as a power of 3, and now we have the left-hand side as a power of 3 and the right-hand side as a power of 3, and of course the left-hand side now looks like the right-hand side, and we can pull out what's equal. So therefore x is equal to 3. Okay, let's try another question. So let's say you have 4 to the power of x is equal to 32. So we have the left-hand side as a power of 4, and we have the right-hand side, and straight away we're going to want to maybe try and get it as a power of 4, okay? But if you've spotted already, or maybe you've done a little bit of work on the calculator, I cannot get a result of 32 from doing powers of 4. All right, so straight away I've got an issue with this one. So my only option then now is to manipulate both sides. Can I write this as a power of a particular number that I can also write this as a power of that same number? Okay, so I'm going to give you a hint with this one. What we can do with 4 is write it as a power of 2. And of course what I can do with 32 is also write it as a power of 2. So what I'm going to do in this particular example is manipulate both sides of the equation so I can get the left-hand side looking like the right-hand side. Pause the video if that's enough of a hint to get working on this one. Otherwise, watch closely and I'll go through it. So since I've spotted that I cannot write 32 as a power of 4, I'm then going to see what number can I write both of them powers of. So 4, as I said, is a power of 2, or it can be written as 2 to the power of 2. So instead of 4 to the power of x, I can write 2 squared to the power of x. And 32 can be written as a power of 2 because 2 to the power of 5 is equal to 32. Okay, because 2 times 2 times 2 times 2 times 2 is 32. Now, here's where your laws of indices comes in. When you have a power to a power, what can you do with the powers to tidy it up or simplify? Well, if you look here to our third law, when you have a power to a power, you can multiply the powers. So when you have 2 squared all to the power of x, it's the same as 2 to the 2 times x, which is 2x. And of course, that's equal to then 2 to the power of 5. Now I have the left-hand side as a power of 2 and the right-hand side as a power of 2. They're both looking the same, so now I can equate the powers. So therefore, 2x must equal to 5. And now go one step further and solve for that x. Well, if 2x is equal to 5, how do you get rid of that 2 that's attached or multiplied? Well, you do the opposite, you divide. And if you divide the left-hand side by 2, remember, you've got to divide the right-hand side by 2. So I'm left with x is equal to 5 over 2, or 2.5. Okay, let's try this one. So we can see we've got a power of 7 on the left-hand side, and we're dealing with powers of 7 on the right-hand side. Okay, so that's good. We obviously want to get it as powers of 7, but we do need to tidy this up and simplify it. And again, that's where your laws of indices comes in. So this one relates to our second law. If you have division, what can you do with the powers to tidy it up? You can, of course, subtract the powers. So we have 7 to the power of x on the left-hand side and 7 to the power of 5 minus 3 on the right-hand side. So that leaves you with 7 to the power of x is equal to the 7 to the power of 2. Now your left-hand side looks like your right-hand side, and of course we can equate our powers. So therefore x is equal to 2. Okay, so here's another question. Pause the video if you want to give this one a go. Here obviously I've got powers of 5, and on the right hand side I obviously have a 5 involved, but what I need to do now is write this as a power of 5. So I have 1 over 5 and I want to write that as a power of 5. So again, if you go to your laws of indices, let's see which one might help us here. If you go to the fifth law here, we have, of course, that a to the power of minus p is equal to 1 over a to the power of p. Well, that will help me rewrite this as a power of 5, because whenever you have 1 over, it's the same as 5 to the power of a minus, and given that's just a power of 1 there, 5 to the power of 1 is just 5, it's going to be 5 to the minus 1. So there's the right hand side written as a power of 5, and the left hand side, of course, is 5 to the power of x. Now your left hand side looks like your right hand side, both powers of 5, and we can, of course, equate our powers. So x is equal to minus 1. Okay, this one is similar, but there is another challenging element in this one. Pause the video though if you feel confident to give this one a go. What we're going to have to deal with here is obviously we've got powers of 4 on the left hand side, and ideally I want to get a power of 4 on the right hand side. But straight away I should spot that I can't write 8 as a power of 4. Okay, 4 to the power of 1 is 4, 4 squared is 16. So I can't write 8 as a power of 4. So straight away I'm going to have to do like I did previously. I'm going to have to change both of these. Okay, so since I can't write 8 as a power of 4, let's try writing them both as powers of 2. Because 4 can be written as a power of 2 and 8 can be written as a power of 2 as well. So let's try that as our first step. So writing 4 as a power of 2, I get 2 squared. And of course, instead of 4 to the power of x, it's going to be 2 squared to the power of x equals. Now, let's keep the 1 over for the moment and just deal with the 8. So writing 8 as the power of 2 is, of course, 2 to the power of 3. So 2 cubed. Okay, so we're still not quite there yet at getting our left-hand side equal to our right-hand side, but we are a step closer. All right, so again, our laws of indices now should help us tidy this up a bit further. So when we have a power to a power, okay, remember this is our third law. When you have a power to a power, you multiply the powers. So we can do 2 times x and get 2x. So that can be simplified to 2 to the 2x. And here we have 1 over. So remember this. This is now our fifth law. Here we go. A to the power of minus p is equal to 1 over a to the p. Okay, so the 1 over, of course, is the same as the minus. And I'm just going to show you this one. This one can often trip people up. The 1 over straight away is the power of minus. Okay, so then what's left? What's left then is 2 cubed. So here is 2 and there's your 3. Okay, so 1 over 2 cubed is the same as 2 to the power of minus 3. All right, and it follows on from this law here. Okay. All right, so we're nearly there. Look, we've got a power of 2 on the left, a power of 2 on the right, and that, of course, means we can now pull out what's equal. The powers have to be equal, so therefore 2x is equal to minus 3. And to get x on its own, to get rid of that 2, of course, we would have to divide. And if you divide by 2 on the left, you've got to divide by 2 on the right. So x is equal to minus 3 over 2, or minus 1.5. Okay, so let's try this one. Again, pause the video if you feel confident. Here, of course, we have a power of 2. So the first thing we want to see is if we can write 64 as a power of 2. And we can. 64, and check it on the calculator if you're not sure, 64 can be written as 2 to the power of 6. So now on the left-hand side, we have 2 to the x plus 1, and on the right-hand side, we have 2 to the power of 6. So we have our left-hand side looking like our right-hand side. They're both written as powers of 2. So then we can equate. That means that x plus 1 is equal to 6. The powers must therefore be equal. And if x plus 1 is equal to 6, take 1 from both sides to get that x on its own, then x is equal to 5. Okay, this one is getting a little bit more challenging, but give it a go. Pause the video, see how you get on. Again, we can see we've got a power of 3 on the right-hand side, so the first thought is to try and make 81 as a power of 3 as well. And we can write 81 as a power of 3. And again, check it out in your calculator. Do 3 to the power of 2, 3 to the power of 3, 3 to the power of 4. Keep checking till you hit to see if you can make 81 as a power of 3. And as I said, you can. 81 can be written as 3 to the power of 4. So instead of 81 to the power of x, we're going to write 3 to the power of 4 to the power of x. Okay, so that's it on the right-hand side. And here we have obviously 3 to the power of x plus 1 on the left-hand side. And then using our laws of indices to just tidy up this. Again, this relates to our third law. A to the power of p all to the power of q is the same as a to the p times q. So we can multiply our powers. So 3 to the power of 4 all to the power of x is the same as 3 to the power of 4 times x, which is 4x. So we have 3 to the x plus 1 on the left-hand side is equal to 3 to the 4x on the right-hand side. So you have the left-hand side as a power of 3 and you have the right-hand side as a power of 3. And now that means we can equate our powers. So we have therefore x plus 1 is equal to 4x. Okay, so if x is on both sides, so immediately what you're going to want to do, of course, is get rid of the fewer amount of x's, and that's on this side. So take away x from that side, and of course, if you take away x from that side, you're going to want to take away x from that side. Okay, you always want to have x's just on their own on one side. So if x's ever appear on two sides of an equation, you want to get rid of the fewer amount of x's completely from that side. Okay, so take away x, and the reason I take away the fewer x's rather than take away the 4x's is just so I can avoid dealing with negatives. All right, so it's just easier to take away the smaller amount of x's. So take away the x completely from that side, And of course I must do the same on the other. That leaves me with 1 equals 4x take away x is 3x. And of course to get rid of that 3 that's attached and therefore multiplied, I must do the opposite and divide. That will get rid of that and give you with x on its own. But of course if I divide the right hand side by 3, I've got to divide the left hand side by 3. And I'm left with x is equal to a third. Okay, so try this question. So we have left on the left hand side a power of 2. And of course our aim then is on the right hand side to write this as a power of 2. Okay, pause the video if you think you know how to do this one. Again, what is going to help us here is our laws of indices. And if you look here at our sixth law, we have that a to the power of 1 over q is equal to the qth root of a, okay? So what's helping us out here is the fact that the minute you see a root, you know you've got to get a fraction, okay? The power is always a fraction. And given that it's just a square root, that means that it is 2 to the power of a half. So now, the right hand side is written as a power of 2, and the left hand side, of course, is a power of 2. So we can go straight ahead and equate the powers. And therefore, of course, x is equal to a half. Okay, let's go on to another one now. A little bit similar, but just putting an extra added element of challenge into it. Let's put 2 to the power of x is equal to 1 over the square root of 2. So the previous one obviously is going to help us out here. All right, pause the video if you want to give this one a go yourselves. The first thing I'm going to do again is I'm going to write the square root of 2 as a power of 2. So I have 2 to the power of x on the left hand side and 1 over 2 to the power of a half, of course, is how we write the square root of 2 as a power of 2. So now I've not quite got it exactly looking like the left hand side. I've got to now deal with this 1 over. And if you remember, again from our laws of indices, this is our fifth law here, okay? So we've got the power of a minus is equal to 1 over. So straight away, I should be spotting that the minute I have a 1 over, it's the same as the power of a minus, okay? And what have you got left? You have 2 to the power of a half, so you must put in 2 to the power of a half. So now, the left-hand side is 2 to the power of x, and the right-hand side is 2 to the power of minus a half. Now I can go ahead and equate the powers, and I end up with x is equal to minus a half. Okay, so again, we're going to add an extra little bit of challenge into these every time. This one, pause the video, give this one a go, see how you get on with it, and then press play when you're ready to look through the solution. Okay, so we have a power of 3 on the left hand side, so straight away that gives us a little clue as to what we want to do on the right hand side. We want to get powers of 3. Now we've got a lot going on the right hand side, okay? So let's just try to do it bit by bit, okay? So first of all, check, can I write 27 as a power of 3? And yes, I can. 27 can be written as 3 cubed. And can I write square root of 3 as a power of 3? And of course, we've come across square root already. And yes, of course, square root is equal to power of a half. So yes, I can write the square root of 3 as a power of 3. Right, that's the first thing to check. So left hand side, keeping it as obviously 3 to the power of x, and right hand side, 27, let's write it as a power of 3. And I can write it as 3 cubed. And then underneath, square root of 3, writing that as a power of 3, as we've already discussed, the square root is the same as power of a half. Okay, so we're getting there. We have everything written as a power of 3, but we still haven't quite got the left hand side looking like the right hand side. So now we have this division here, and again, going to our laws of indices to help us simplify the right hand side. If you look at your second law, we have of course that a to the power of p divide by a to the power of q. All you need to do is subtract the powers. When you have division, you can subtract the powers. So that's exactly what we're going to do here. That's 3 to the power of x then is equal to 3 to the power of 3 minus a half. And of course, 3 take away a half is the same as 2 1/2, or 5 over 2. Okay, now you have the left-hand side as a power of 3, the right-hand side is a power of 3, so we can equate our powers. So x is equal to 2.5 or 5 over 2. Okay, try this question. Press pause, give it a go. So, the left-hand side we've got a power of 2. So on the right-hand side, ideally we want to get powers of 2. So let's check. Can I write 16 as a power of 2? And of course, we can. 16 can be written as 2 to the power of 4. And square root of 2, can I write square root of 2 as a power of 2? And of course, we can. Square root is the same as power of a half. All right. The other thing I want to point out here, of course, is when you have this 16 that's written right beside the square root of 2 and it's attached, like anything else that's attached, of course, that we've come across before, that means it's multiplied, okay? I'm just going to stick the brackets in there to help us remember that that's multiplied. Okay, so on the left-hand side, I have 2 to the x plus 1, and on the right-hand side, I've already said 16 can be written as 2 to the power of 4. And square root of 2 can be written as 2 to the power of a half. Okay, so I've nearly there. I've got everything written as powers of 2. I just need to tidy up the right hand side. And of course, as always, our laws of indices will help us do that. So looking here, which of the laws might help us tidy up this one? Now remember, this is being multiplied. So if you look at the very first one, this is the one that tells us when you have two things that are being multiplied, when the same number in both is being raised, then all you need to do is add the powers. So that's what I'm going to do here. So I have 2 to the power of 4 times 2 to the power of a half, and that's the same as 2 to the power of 4 plus a half. Okay, so that's the right hand side. And now 2 to the power of x plus 1 therefore is equal to 2 to the power of 4.5. 4 plus a half is 4.5. So now I have the left hand side as a power of 2 and I have the right hand side as a power of 2, and I can equate. So I have basically x plus 1 is equal to 4.5. All right, so getting x on its own, I will want to get rid of that 1, so take it away. If I take away 1 on the left hand side, of course, I have to take away 1 on the right hand side. So 4.5 take away 1 is 3.5, and that is my answer. Okay, so we're getting even more challenging now with this one. And the great thing about these questions, it really does help you work through your laws of indices and how to manipulate them, okay? As well as be able to solve for the indices. All right, this one's tricky, but take your time. Press pause if you feel confident to give it a go. I'm about to give you a hint if you want a hint before you press pause, okay? But by all means, if you're confident, try this one before you hear the hint. If I was giving you a hint on this one, of course, the first thing I'm looking for is if the left-hand side is a power of 4, I'm asking myself, can I write 32 as a power of 4? And can I write 8 as a power of 4? And the answer is no, I can't. I can't write 32 as a power of 4, nor can I write 8 as a power of 4. So I mustn't be looking to write these as powers of 4 at all, in which case I'm going to have to manipulate both sides of this equation, okay? So what could I write 4 as a power of that I could also write 32 and 8 as a power of? And the answer is 2. I can write all of these numbers here, 4, 32 and 8, all as powers of 2. So that's what I'm going to do. So instead of writing 4, I'm going to write 2 squared, okay? And instead of 4 to the power of 2x plus 1, I'm going to write 2 squared to the power of 2x plus 1. Okay, 32 can be written as a power of 2. It's the same as 2 to the power of 5. Over square root, keep that in. We're just going to change the 8 next. 8 as a power of 2 is, of course, 2 cubed. Okay, so that's our first step. Now we're going to rely on our laws of indices to start tidying this up, okay? So we can get our left-hand side looking like our right-hand side. So here, of course, we've got a power to a power. And if you remember from your laws of indices, your power to a power, if you have that, here it is, our third law, you multiply the powers. Now, just be careful here. We're going to have to multiply these two powers, the 2 by the 2x plus 1. So I'm just going to put extra brackets around here so that you're very clear that you have to multiply both the 2x and the 1 by the 2. Okay, so it's going to be 2 to the power of 2 times 2x plus 1. I'm going to multiply those together to tidy up that left-hand side. And on the right-hand side, well, there's still quite a lot to have to tidy up here, but the first thing I'm going to want to deal with is the square root. And of course, square root is always a power of a half. So I'm going to write 2 to the power of 5 over 2 cubed. The only thing I'm going to do in this step is write the square root as a power of a half. Okay? Right, the next step. So I'm going to multiply out these brackets because I'm multiplying these powers on the left-hand side to tidy it up. 2 times 2x then is 4x, and 2 times 1 is 2. So there we go. There's the left-hand side tidied up. And the right-hand side, again, there's still quite a lot to do. All I'm going to do in my next step is do under here where I have a power to a power. And we've already discussed if you have a power to a power, you multiply the powers, okay? So I have 2 to the power of 5 on top over 2 to the power of, and 3 times a half. That's what we're doing. We're multiplying these powers. 3 times a half, of course, is 1.5, or 3 over 2. Okay, so now let's keep, there's nothing more we can do with the left-hand side. We have that now as a clear power of 2. Although I know the power is quite complicated, but there's nothing more I can do with that left-hand side. I have it as a power of 2, a single power of 2. That's what I want. The right-hand side, there is another step further. If I have division, of course, let's go back to our loads of indices. Remember, the other bit of tidying up you can do, if you see division, you can, of course, subtract the powers. So that's what I'm going to do. 2 to the power of 5 take away 1.5, or 3 over 2. All right, so that leaves me with 2 to the power of 4x plus 2 is equal to 2 to the power of, and 5 take away 3 over 2, or 5 take away 1.5 is, of course, 7 over 2. All right, 7 over 2, or 3.5. Okay, now you can use the 3.5 if you prefer. I prefer to keep it as a top-heavy fraction, but it doesn't matter at this point. We're still going to now solve for x. So whether you have it in decimal form or 3.5 mixed fraction form, you'll still be able to solve for x. So now we have a power of 2 on the left and power of 2 on the right, and we are going to equate our powers. So that means that I have 4x plus 2 is equal to 7 over 2. And again, don't worry too much that we're dealing with these nasty fractions. You can have that, of course. Your calculator will do all the hard work for you. The first thing you're going to want to do, of course, is take away 2. All right, 2 from the left-hand side to leave you with the 4x. And 7 over 2, take away 2 is, of course, 1.5. Okay, or 3 over 2. And then to get rid of the 4, I'm going to divide by 4. So dividing both sides by 4, and again you can do this on the calculator. 3 over 2 divided by 4 is, of course, 3/8. So the answer is 3/8.